Hello everyone, welcome back to the channel. So in today's video, we are going to solve another very popular LeetCode problem, reverse integer. So this is the LeetCode problem number 7. So in this video, we'll understand what the problem is asking, the logic behind reversing an integer, how to handle negative numbers, how to avoid integer overflow, and finally implement the optimized solution in CPP language step by step. So this problem is really important because it teaches modulus operator, integer manipulation, edge cases, and overflow handling in interviews. So let's get started. So first, let's understand at first, let's understand the problem statement carefully. So, we are given a signed 32-bit integer x, signed 32-bit integer x, written x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, this to this, then return 0. Assume the environment does not allow you to store 64-bit integers signed or unsigned. So here our task is to reverse its digits. So let's take some examples. So example one is x is 1, 2, 3. So after reversing, our number becomes 3 to 1, 3, 2, and 1. Uh, if like if we take another example but with a negative number, x is -1 2 3 and output becomes -3 to 1. The negative sign should not change, it should remain the same. So negative sign stays, only digits are reversed. So another very important condition, if the reverse number goes outside the 32-bit integer 32-bit integer range, we must return 0, and the 32-bit integer range is this. So this is the most tricky part of the problem. So now let's think logically. So how do we reverse digits? Like suppose we take 1 2 3 and we want 3 to 1. So we use modulo function. Like we can simply use modulo function like x percent 10, which will give 123% 10, which is equals to 3. And then remove the last, digit. So, so 123 slash 10 becomes 12. So this is the basic logic that we are going to use in this. Like we will use the modulo function and division function. So this is how we are gonna do. So we can process digits one by one. So now the main logic. Now let's build the reverse numbers. Suppose x equals to 1 2 3. mm, X equals to 1 2 3. Initially we will create a variable ans and set it initially at 0. So after we will store every value as ans start 10 plus digit, and here digit will be x modulo 10. So we will perform all these steps in a for loop, or a while loop, whatever you want, and that will give us the reversed number. You'll better understand while coding. So let's begin with the code. So at first we will create a variable zero, a variable answer and set it be default zero. So while x is not equals to zero, int digit equals to x modulo 10, x modulo 10 if ENS is greater than int underscore max slash 10 or ENS is less than int underscore mean slash 10, we will simply return 0. We have here used this condition to check if it is in the 32-bit integer sign range or not. If it won't be in the range, it will simply return 0. So it is the most trickiest part in this question. So now continuing, uh, we'll set ANS equals to ANS star 10 plus digit. And at last, x equals to x. We will return 10. So let's just submit it, check if it is correct or not. So as you can see guys, the solution has been accepted for all the possible test cases. Now submit and check if it is correct for all test cases or not. As you can see, our solution is absolutely correct and accepted for all the test cases. So now let's understand this code quickly. So at first, our integer variable value of ENS is 0. So then, while we have used a while loop here, loop runs till the digits remain. So int digit equals to x modulo 10, and here we have used the if condition to check if uh, if to check the overflow. If this condition is true, we will simply return 0, and if it is not, then we will build the reversed number. So at the end, we will just return the reversed number. So now let's analyze its complexity. So we process every digit once. So time complexity becomes order of n because number of digits is logarithmic. Complexity will become order of log 10 of n, log 10 n. But log 10 is 1, so it will simply become order of n. So, and the space complexity becomes order of 1 since we have only used a few variables. So that was the complete explanation of LeetCode 7 reverse integer in CPP. So here we covered problem understanding, integer reversing logic, overflow handling, code explanation, and complexity analysis. If you found this video helpful, make sure to like the video, subscribe to the channel, and comment which lead code problem you want next. Thanks for watching, and I'll see you in the next video. Thank you.